Let's take a look at another example. Suppose we know an investment decreases by 2% each week. How much has been lost after 8 weeks? So the first thing I need to do here is to write the function. So now when I write my function, you'll notice that I do not know how much I started with, but that's okay. I'm just going to put in a filler for that. So when I go to put in, write my equation, I'll do A equals, I just A for amount. A equals, I don't know the initial amount, so I'm just going to call it A sub 0. That stands for the initial amount. Now to get my B, I notice I'm decreasing. And so since I'm decreasing, I have to use 1 minus R. So I'll have 1 minus the 2%. So 1 minus 0.02 raised to the t. So the formula I'm going to use is A sub 0 multiplied by 0.98 to the t. And the A sub 0 is just this random initial amount. And it doesn't matter whether that initial amount is 1 or 100 or 12. So I can just call it A sub 0. It'll take the same amount of time, or I'll have the same part of what was of the whole left after 8 weeks, regardless of how much I start with. So now I want to know how much I do have, or what part of the initial I have after 8 weeks. So I'm going to evaluate this function at 8 weeks. So I do A sub 0 multiplied by 0.98 to the 8th. And if I do that math out, I end up with 0.85076. On these exponential functions, it will be helpful to carry a lot of decimal places. It will make it much easier when you need to check the answer in the back of the book. They may use fewer, but if you use more, you're going to round to exactly what they would have. So what I now notice, though, is I actually have 85.076, so about 85.1% of the original remaining. So that's what that tells me, is I have about 85% of the original remaining. Now this didn't ask how much of the original was left, it said how much has been lost. So if I think of the fact that I have 85% remaining, I have almost 15% that's been lost.